Hello class, today we're taking a look at some equations that have decimal coefficients and constants. So we've started with this guided practice here, and it's important to remember that of course we are going to be following the same 4 steps as we always do for solving equations. We're just going to have to obviously deal with some decimals. And we talked about having 2 options there. Just deal with the decimals, work with the decimals. We know how to add, subtract, multiply, divide decimals. Or we can look at eliminating the decimals. And for each person, one of those might be easier than the other. In terms of complexity or time taken or anything like that, they are about equal. So in the guided practice, we're trying the same problem using both methods, and you kind of want to look through as you're doing that to see, well, which method it makes more sense for my particular brain overall. So if we start with question A, we have this equation here, and we're going to begin by just dealing with the decimals using our decimal operations. So the first thing I need to do in this equation, since there's no brackets, is step 2. I want to go ahead and collect my positive x's. If I look at my 2 coefficients here, my negative 1.8 is a larger coefficient than negative 6.2. Of course, if you think temperature, right, negative 1.8 is hotter than negative 6.2. So the 1.8 is the side I want to leave. That means I need to cancel out my minus 6.2x on the right side. And the opposite of minus 6.2x is plus 6.2x. So we'll do the same to the other side. We'll plus 6.2x. Now on the right side, our minus 6.2x and our plus 6.2x cancel out. We do still have our 9.8 constant. On the other side, we do need to think about our integers here. So remember when we add integers with different signs, we've got negative 1.8 and plus 6.2. We're actually going to subtract those numbers. So to do the subtraction, we need to borrow, and we get 4.4. Now the positive team was bigger, so this will be positive 4.4x. And we do still have our coefficient, our constant there of 4.3. Next thing we're going to do is our addition or subtraction. So looking at our x here, what is being added to that is 4.3. The opposite of adding 4.3 is subtracting 4.3 from both sides. On the left side, positive and negative 4.3 cancel out. And on the right side, this is a subtraction we can do. 8 take away 3 is 5, dot is dot, 9 take away 4 is 5. And of course, we still have our 4.4x on the left side. That is not canceled out. Final thing we're going to undo is our multiplication and division. X currently being multiplied by 4.4, so the opposite of that is to divide by 4.4. We'll do that to both sides. We're left with just a single x on the left, and on the right we're going to need to do our division. So let's go ahead and divide. We got our 5.5, which we want to divide by 4.4. We're going to move those dots once, and that'll give us the problem 44 divided into 55.0. Now 44 goes into 5 0 times, 44 goes into 55 1 time, which makes 44. Okay, and that's going to use up our, or leave 11 of those 55 remaining. And we're going to bring down our 0. Now we want to know how many times does our 44 go into 110. It's going to go in twice, and that'll use up 88 of our 110. Taking away leaves us with 22. And we'll bring down our next 0. If you count up how many times 44 goes into 220, it does go in 5 times, and it goes in exactly 5 times, leaving us with a remainder 0. So we can conclude that x is the number 1.25. Now, if all that decimal stuff is not really your cup of tea, we can always eliminate the decimals. And to do that, we're going to multiply by the lowest place value that any of our decimals reach. So if we look at all of our decimals, they've got one place after the dot there, and that's the tenths place. Since they're all in the tenths place, multiplying all of them by 10 is going to eliminate our dots and give us a nice whole number equation. So 10 times negative 1.8 is negative 18. 10 times positive 4.3 is positive 43. And of course, our 10 times 9.8 is 98, and 10 times minus 6.2x is negative 62x. So once we've done that expansion, we can go ahead and just work with all our whole numbers in this new equivalent equation. So again, I'm going to start by collecting my x's. Negative 18 is bigger than negative 62, so we'll go ahead and cancel out our negative 62 by adding 62 to both sides, just like we did over here, but without our dots, we are going to get 44x as the result of that step. We still have our constant, and we still have this constant over here. Next, we're going to undo the addition. So the opposite of adding 43 is subtracting 43. Guess I've been using blue for that. And that'll give us 44x is equal to 8 take away 3 is 5, 9 take away 4 is 5, 55. And then the opposite of multiplying by 44 is dividing by 44. That'll give us x equals 55 over 44. Now I'm going to go ahead and divide each of those by 11 to simplify this fraction. And that gives me 5 over 4, which is 1 1/4, which is my same 1.25. So depending on your brain, you may find that right side or that left side, dealing with the decimals or eliminating the decimals easier for yourself. But obviously, both of them get to our same answer of 1.25, and we'll verify that a little bit later on. In question B, same type of deal. So we're going to start by doing our decimal work first, and then we'll think about how to eliminate those decimals. Okay, so starting with our dealing with the decimals, we're going to want to collect our x's. We do have x's on both sides of this equation, and so we want to go ahead and keep the side that is bigger and cancel out the side that's smaller. So if we compare 2/10 to 7/10, obviously 7/10 is bigger than 2/10. So we're going to leave the right side and we want to cancel out the left side. The opposite of plus 0.25x is minus 0.25x. Of course, we'll do that to both sides. Okay, we still have our constant 3.5 on the left side. On the right side, if it was 0.7 take away 0.2, that would be 0.5. Take away a further 5/100ths, that's going to be 0.45x. Then we still have our constant of 2.15. From here, we're going to undo our addition. So the opposite of adding 2.15 is subtracting 2.15 from both sides. Of course, when we do this subtraction, we want to remember that we do have our placeholder 0 in that 3.5, and so we're going to need to borrow to do this subtraction. So 10 take away 5 is now 5. 4 take away 1 is 3. Dot is dot. 2 take away 1 is 2. So 1.35 is the value of the left side there. And on the right side, our 0.45x is left. Finally, we'll undo our multiplication. So the opposite of multiplying by 0.45 is dividing, and we'll do that to both sides. So let's go ahead and do our division. When we do this division, we'll have our 1.35. We'll want to divide that by 0.45. We're going to move our dot twice and move this dot twice as well. So the real problem we're doing is, 45 divided into 135. So if we count up our 45s, that'll give us 90. Another 45 gives us 135. So we can just say this goes in 3 times exactly. So we can say that 3 is the value of our x. If we want to solve by eliminating decimals, we need to look through our whole expression and find the lowest or smallest place that any of our decimals reach. We see that these two decimals reach the hundredths place. And so we need to multiply all terms by 100 to eliminate all of the dots. So let's go ahead and multiply this side of the equation by 100 and this side of the equation by 100 as well. Remember to distribute that into all the terms. So 100 times 3.5 is going to give us 350. 100 times 0.25x is going to move the dot twice and become 25x. 100 times 0.7x moves the dot twice, which will become 70x. And 100 times 2.15 moves the dot twice, that'll make 215. From here, let's follow our same steps. We'll start by collecting our x's on the right side of the equation. That'll give us 350 is equal to 45x plus 215. We'll go ahead and undo our addition of 215 by subtracting 215 from both sides. And again, we'll have to borrow. So 135 is equal to 45x. And we'll finish up by undoing that. multiplication by 45 by dividing by 45. Now you might notice that 135 divided by 45 is just this calculation we did here. So the answer is going to be the same. Of course, it's just 3. So the kind of moral of the story here is it doesn't really matter whether you eliminate the dots or not. Some people are more comfortable if they eliminate the dots, but you're going to be doing the same calculations in kind of the same way. So it's really up to you just in terms of which one you're more comfortable with. Obviously, whether you remove the dots or not, you should get the same answer for in a certain equation. So let's verify our solutions. In question A, we thought that x was 1.25. So to verify that, we're going to go ahead and substitute that in. And we think x is the number 1.25. And of course, we have to substitute that into both sides of the equation. Just copying out everything except the x is there. So let's go ahead and do our calculations on each side. I'm going to start with this multiplication. So I need to do 1.25 times my 1.8. And of course, negative times positive will make negative. 8 times 5 is 40. 16 plus 4 is 20. 8 plus 2 is 10. 1 times 5, 1 times 2, 1 times 1. And we had 3 digits behind dots, so this is 2.25 here. And sorry, that is negative, of course. Negative times positive. To finish up, we're adding our values with different signs here. So we're in fact going to subtract those numbers. Oops, 0.2. So the value of the left side is 2.05. Remember, we don't really care what exactly the value is. We just want it to be the same as the value on the right side. So let's figure out what the value on the right side is. Again, we'll start by doing this multiplication. Ten, 4 plus 1 is 5, 2 times 1 is 2, 6 times 5 is 30, 12 plus 3 is 15, 6 plus 1 is 7, and 3 digits behind dots. So we got 9.8, we need to take away from that 7.75. Again, we'll need to borrow there. And we do, in fact, get the same value of 2.05 on both sides. Okay, now again, we don't really care what number we get on both sides as long as it's the same number. So since we did get the same number on both sides, we know that our original solution of x equals 1.25 is in fact correct. If we take a look at question B, a little bit easier since we thought the solution was x equals 3. So let's go ahead and substitute in 3 for the value of our x's, and we'll do our calculations. So we'll start with our multiplication. 0.25 times 3 is 0.75. Again, you could long multiply there if you had to. And my 0.75 plus my 3.5 is 4.25. On the other side, I got 0.7 times 3, which is 7 times 3, move the dot once, or 2.1. And 2.1 plus 2.15 is 4.25. So again, we see that in fact our left side does equal the right side. Same value on both sides of the equation. We know our solution of x equals 3 is in fact correct. So I hope that's helped with your understanding of how to solve an equation that has decimal coefficients and constants.